Saxon Algebra 1, Lesson 15. Welcome, greetings, gentlemen of Algebra 1. We have a one-topic lesson today, and I couldn't be more excited to bring it to you, although, I'll be honest, you guys, it's not my favorite. It's surface area. Remember that when we have three-dimensional objects, like this one, sometimes we find the volume of them, right? We find the volume, and that's, the space that it fills up. But other times what we want to do is measure all of the outside surfaces, not the inner dimension, but again, I think of this as we want to figure out how much magic wrapping paper we need. Magic wrapping paper, it's kind of like contact paper in that it just sticks to it and you don't have to fold it or overlap it. It's just like a perfect thin layer of paper that covers the box. And we want to learn how to calculate that amount. Now, we can take a drawing like this, and this is a super easy problem. It's going to get real hard real fast. But you've done it before, so it's fine. We need to know the length, the width, and the height. That's generally what we call these dimensions, but honestly, the names don't matter. As long as you have the dimension of each direction, who cares what they're called, right? When we're looking for the surface area, what we have to do is break the shape down into its basic shapes and find the area of each one. So in this one, we have all rectangles, right? And what's interesting, let me make this kind of look dimensional. Right? In this one, we have a front and a back. So I'm going to write front, back. And then we have a side and a side. And we have a top up here and a bottom down there. And each of those three pairs is going to be a unique size because we can see the box is different in each direction. But each of those two sides that are paired together will be the same. In all of these calculations, we're finding rectangles. Later, that's going to change. We won't be finding the same shape. So what I'm doing now may seem like overkill, but soon it's going to be helpful. So the first thing that we write is the formula to find the area of that specific shape. All right? Now we're going to go back and fill in the numbers for each of those sides. The front and the back, that's this space here, as well as that one. So the length is 4, and the width, we called it the height, but that's when we thought of it as three-dimensional. Now that we're just looking at this rectangle, that's the width, right? So it's 4 times 2. So that's 8, but we have 2 of them, so we count it as 16 square, whatever our unit is. We'll add that in later. It's centimeters. By the way, this is example 15.1. Okay, so now we've done the first one. Side to side, that's this dimension. It's 3 by, and we have to look at a different part of the diagram, 2. So that's 6, and we double it because there are 2. And then the top and the bottom, that is 4 by 3, which is 12, and we double it, and we get 24. And then the last step of a surface area problem is to add them together. I'm going to put the 6 and the 4 together. That's 10 plus 2 is 12. 1, 2, 3, 4, 5. 52 centimeters. And it's always a square. The surface area is because we're working in 2 dimensions, right? We're measuring the area of the outside shapes, not the inner part, because that would be volume and that's 3-dimensional. Okay, that was the easy one because it was just rectangles. Let's make it harder. This one, do you guys remember that candy called Toblerone? It's still around, but they used to have a triangular box, and it makes me sad that they don't sell it that way anymore. Guess it cost too much, but it was perfect for this lesson. All right, find the surface area of this right triangular prism. It's just a fancy name for a 3-dimensional object. Dimensions are in meters, okay? I'll just circle that to remember for later. These numbers are all on here. I'm not figuring these out. Okay, and I like to, it helps me, again, like I always say, draw the diagram. It helps you understand what you're doing better. I like to put in the little dotty lines to be like me looking through the shape because it helps me understand the pieces of it better. I did it there. I like to do it on all of them. Plus, it's just fun to draw. Okay, so this one we go through again and we look for any matching sides and pair things together and just make a list of everything we need to do. This triangular shape on the front has the very same one on the back. So the first thing I'm gonna do is I'm gonna write front, back, and I'm gonna draw a picture of a triangle because that's the shape. All right, then the next one I'm gonna do, I'm gonna call the side, and that's this rectangle that's kind of at the back of it. If you think of this as like a slide, this is like the ladder going up, right? And that is a rectangle. And what did I call that? I'm gonna call it the ladder. And then we'll need to do the slide, right? That's this part, another rectangle. And then this I'm gonna call the base because it's the part that's on the ground. So we have 5 sides. Let's count and make sure that's right. 1, 2, 3, 4, 5. Beautiful. Now, most of these are rectangles, so I'm going to write in length times width. The top one, the front and back, that's a triangle, so we need that formula. That's base times height divided by 2. All right, so organizing my formulas right off the bat is going to help me work smarter and cleaner. All right, I want to do the easy ones first, just so that my head doesn't get muddied when I go to do that one. It's not that much harder, but I like to do the easy stuff first. It makes me feel like I'm accomplishing something. So here's the base. This 5, I'm checking the diagram to make sure I understand. This 5 relates to that hypotenuse edge. This 3 is the bottom, 4 is this, and 6 is this edge. This 5 was kind of floating in the middle of all those lines and it was difficult to see. Okay, so the base is 3 by 6. That's 18, and I only have one of them, so I don't have to multiply it by 2 like I did here. What about the slide? That is 5 times 6. That is 30. What about the ladder? This part back here, that is 4 times 6, right? That's the same as this. So it's 4 times 6, that's 24. And again, we only have one of each of those. Now we're up to the triangle. We need to do base times height divided by 2. So here's the base of the triangle. I'm gonna just give myself a little more space. Times the height, it's right there, divided by 2. But I also know we need 2 of them, so I'm gonna multiply it by 2 because we have 2 triangles. What that does is really nice. It cancels out those 2's, and I know that the area of both triangles is 12. Okay, now I'm ready to add. Is this confusing? This is divided by 2 because that's the formula, but we multiplied it by 2 because we have 2 triangles. So I was able to cancel those, and my calculation was nifty simple. And so now I'm ready to add these up. 14, 1, 2, 3, 4, 5, 6, 7, 8. 84 meters squared. Surface area is always squared. Yay! This one was right too. Yay! Okay, the shapes are going to get a little bit trickier. And there are how many in all of these? There are 4. So we're half done. But we did the easy ones, but that's okay. We're tough. We can handle this, you guys. Example 15.3. No, 15.3. That's how I should say it. All right. A right circular cylinder has a radius of 4 inches and a height of 10 inches. And John does show us a picture. It's not just words. Okay? A right circular cylinder. Those words mean that this side comes straight down and makes a right angle with the base. That's good news. That means it's an easy, simple shape. Circular cylinder just means that it's got a circle on the bottom and then it's rounded like a can of soup. It's got a radius of 4 inches, which John is showing us right here. There's the 4. And a height of 10 inches, as shown. Find the surface area of the right circular cylinder. Okay, so here's what we're going to do. You guys know what box cutters are? It's like a sharp knife, a handheld knife with a triangular blade. Most dads have them in their garage. I mean, moms for that matter. But they're handy little knives, and we're gonna take a shape that looks exactly like this, but it's three-dimensional and it's in our lives and it's made of cardboard, and we're gonna pick it up and we're gonna start slicing this. I'm gonna quickly draw it on my page. It's perfectly straight. Oatmeal comes in containers kind of like this. That's the best thing I can help you imagine, okay? And let's see, the height is 10. And the radius is 4. I'm gonna draw mine on the bottom because I've got a little more space. It's easier to see there. Okay, so what we're going to do is we're gonna take that knife and we're gonna slice this up. We're gonna cut off the top and have a perfect circle. We're gonna cut off the bottom and have another perfect circle. Then we'll have a tube, right? If you pick it up, you can look through it, yell at your brother through it, whatever you wanna do. Maybe if you were a little kid and this was big enough, you could crawl through it, right? We're gonna take that and then we're just gonna slice it down one edge. And then we'll be able to open it up and lay it flat, and it will be an amazing, beautiful piece of cardboard. And let's say this is advanced technology cardboard that once you open it, it loses its curl and it lays perfectly flat. Because that would be really annoying if it kept curling up, right? But no, this lies perfectly flat and is just a nice little rectangle. That's how we convert this three-dimensional object into two-dimensional shapes that we can then measure, okay? Oh, that's nice. We got that out of the way. The box cutters are handy for our surface area problems, so keep them close by. Now, we need to find the area of the two circles and the rectangle. So let's write down our formulas. The area of a circle is pi r squared. These circles are exactly the same, so we don't have to worry about two calculations. We can just calculate it once and then double it. And we know that pi is equal to 3.14. I'm gonna write, before I was writing all the way across, this time I'm gonna go down a little because I don't have enough space. Pi is equal to 3.14, and our radius is 4, right? I'll just jot that right there. So this is gonna be 16, right? 4 squared is 16. So if we multiply those out, let me do it down here. Go ahead and you multiply it out yourselves. And then we'll compare at the end. I get 50.24 is the area of one of those circles. We have two of them, so I'm just gonna write, I'll just add it separately in the total column, all right? So there's 1 and 2, there's 1 and 2. Okay, we've got the circle taken care of. Now, for our rectangle, that's length times width. And we think, oh, that's really cool, that's easy, right? And we can see on our rectangle, which is just like this one, this dimension would be 10, right? Because it's the height. But how do we find this dimension? Okay, ready? This is the part that's a little bit mind-blowing-y. When we took our box cutters and cut around the top, let's say this one's the top circle like this, this was the other side of that cut, right? So if we took this edge, we could wrap it around this circle and it would go exactly around once, right? Because this was round and it fit around there. That means that this length is equal to the circumference of that original circle. Good to know, right? The bad news is that means we have to not only calculate the area of a circle, but we also have to do the circumference of the circle in order to get this measurement. So circumference equals pi 2r, and in this case that would be 3.14 times 2 times our radius is 4. Got it? That's all good. This becomes 3.14 times 8. Now let's just look at something. We just multiplied 3.14 times 16, and now we're multiplying it by 8. 16 is half of 8, so this product will be half of this. Do you see how I made a fun little shortcut there? I noticed that these two factors were quite similar. First we multiplied it by pi by 16, then we multiplied it by 8. 8 is half of 16, so this is my answer. It's half of this. I just mentally, I chopped 25 in half, and then I chopped, I thought of it as 24, even though it's technically 0.24. And I got 25 for half of that, and 12 for half of that. So that is my answer. Now, that is this number. 25.12. We have to multiply it by the height, which we said was 10. So I have to do 25.12 times 10. But that's really easy because all we do is bump the decimal place. And so the area of this whole rectangle-y bit is 251.20, right? I just bumped to that, and I'll draw a little arrow going up. That's where we got that. All right. Whew. Are you confused yet? Do you need a sandwich? I mean, come on, this is a lot, isn't it? All right, our final step is to add together the three pieces. This one only has three pieces, right? The top, the bottom, and this middle section. We add 8, 6, 1, 351.68. What's our units? Inches. Inches squared. And is that the right answer? Yay! It is. That is the right answer. It's a lot of work. Look at that. I wrote fairly tight, and it still took almost half. It took a half a page, plus a little bit more. These take room. Please generously spread your work across the page. Do not cramp it in and make it tight. You guys, if I could change any habit in my students, that would be to put breathing space on your page, okay? It will stress you out less if your homework has room to breathe, and it will stress out the people who are looking at it less if they can actually see what you're doing without it just being a mad scramble. So please use plenty of paper. I once had a student, I knew him really well, so it wasn't as bratty as it sounds, but he told me that he couldn't do that because his mom didn't want to waste a lot of money in buying him spiral notebooks to do his math, and that if he spread it out like that, she was going to have to buy too many. And I said to him, Ben, because that was his name, Ben, if you find that your mom won't buy you the spiral notebooks that you need to do your math homework if you spread it out, just let me know. I will buy you math books all year long. I'll buy you spiral notebooks if that's what it takes. But please, spread out your work. So I make the same offer to you. If your mom says, sorry, you're wasting space, I'm not buying you any more of those pricey spiral notebooks, just give me a holler and I will hook you up, because I really want you to spread out your space, your work. Okay, one more. Now this is the way John often shows these. The base of a right solid 10 feet high is shown. Find the surface area of the right solid. Okay, right solid, again, it means that the sides are at right angle with the base. That's good. That means it's easier. Solid just means it's three-dimensional, but it's a weird shape that we don't have a name for. Perfect. Now, what John is doing is he's showing you the object, which to me, looks like an old-fashioned mailbox lying on its side, right? Like this is the part that would open and the mail would go in. But John also gives us a map of the base. So this is a map of, it's the top and the bottom. But this way, when we go to find the area of this creature, we will have a good diagram to work from. So I'm not going to copy the three-dimensional object, but I am going to copy this creature. And we've worked with these before, haven't we? These are not altogether new to you. I'm putting in all the details that the book has. As I put in the radius, I remember, oh yeah, the radius is not only this distance, but it's also this distance and this distance. So this will be 6. And if John tries to trick me, oh, he doesn't. He tells me that. But remember that the radius can be used to find that dimension. And then this is 5. All right, and we know that the height of this thing is 10 feet high. We'll need that later. All right, I could draw that little mailbox lying down thing, but I'm not going to because I don't want to spend my life doing math, and that diagram won't help me that much. It doesn't have any numbers on it. Okay, dimensions are in feet. That will come in handy later. All right, so we get our box cutters. I'll show you again. We get our box cutters, and we're going to cut off that shape and the bottom shape first. I've also had students, I don't know if it was exactly Ben, but it was definitely his classmates. They thought that looked like a toilet seat. And I said, sure, why not? I can see that. So we take off the top, we take off the bottom. Now we cut down through the sides. Let me show you what I mean. We take our box cutters and we're gonna cut it right here. Okay, so when we open it flat, there's gonna be a crease there, but then that will just be the bendy part. So it's not important necessarily to do this, but I'm gonna show there's the crease, this was the bottom, and then this part was the part that flipped over, okay? And the height we said was 10, so that's gonna be this dimension. All right, so now we have to figure out what's the area of this whole thing. All right, well, there's gonna be 2 of them. They're gonna be exactly the same. So once we figure out one, we'll just double the number. But here's the annoying thing. This shape is actually made up of 2 shapes. So first we have the rectangle-y bit, that's length times width, and then we have half of a circle. How do we find the area of half a circle? Well, we find the area of the whole circle divided by 2. Lord have mercy. This is a lot, isn't it? Okay, so the rectangle, length times width, 6 times 5, that's 30. The half circle is pi, 3.14, times r squared. The radius is 3, so that's, excuse me, that's a 9. And then we divide it by 2 because we're taking half a circle, not a whole circle. All right, 3.14 times 9, because we don't use calculators, because we are tough. 3.14 is, or 9 times 4 is 36. 12, 28, 2 decimal places, there we go. But we also have to divide it by 2. Luckily, I can do that in my head because 28 divided in half is 14. And 26 divided in half is 13. So the area of the half circle is 14.13. That means, no, 14.13, excuse me, sorry. The decimal's here, so we line those up and we get that this is 44.13 is the area of one of these. So I'm gonna write it down again because we actually have 2. Okay, so we've done these guys, we're set with those. Now we have to deal with this rectangle. Oh, rectangles are easy, you say. This is, okay, so that was a different thing. This rectangle was for this. This is a different rectangle. So this is length times width again. We know that dimension is 10. I'll put that in as the second one. But how do we find this dimension? Oh, it's circumference again, you guys. We have to find this, 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 and this. Oh my gosh, right? because that's the length of this, is the distance that goes all the way around here. So the length equals, let's start here, 5 plus 6 plus 5 plus, how do we find this? Well, that's half the circumference. So we have to take the circumference of half a circle, which we talked about, it's pi 2r divided by 2. So we can shortcut that as just pi r. You don't even have to memorize it, just remember that you can cancel those 2's. Up here we couldn't because there isn't a 2 in it, it's a squared, and you can't just cancel that. All right, so pi times the radius is going to be the circumference of half the circle, and that is 3.14 times 3. So let's do that calculation. 2 decimal places, 9.42. All right, side, 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 half a circumference. That will equal that whole dimension. Let's add it up. 0.42. I'm going to go 9 plus 11 is 25. All right, so that is the length. And so that's what we're going to multiply by 10. Do you have a headache yet? I would if I were you. I would be crying. Maybe you are crying. That would make me feel terrible. I don't think you are. But what if I made a student cry? I have not made a student cry, but I have had students cry to me before. And it's usually, I mean, you know how this goes. It's usually when they're doing terribly and they have to confess to me. And oftentimes there's a cheating scandal involved, you guys. I've had many a cheating scandal in my day. Sometimes students just lose their minds and stop doing their homework, and they sooner or later have to confess. Oh, my friend Ben, what did he tell you about with him? I told you something about my student Ben. At one point, he got 30 lessons behind in his homework, and he had to confess to me. He didn't cry, though. He didn't act like it was any big deal. He's like, I'll catch up. And you know what? He did. He did a really good job. Okay, so the area of the rectangle is, you just bump the decimal place because we're multiplying by 10, 254.2. Yes. John agrees. So we add that to our list, 254.2. And I'm going to put in a 0 so that we have the same number of decimal places in all of these. You can. It helps keep things neater, but you don't have to. All right, ready? Our last part of this problem is to add together the 3 components, the 2 toilet seats and the part around the middle. All right, ready? Yay! 342.46 feet squared. That's our final answer. Look at all the steps. You guys, if you don't keep this organized and well thought out, no one is ever going to be able to make sense of it. And I want you to practice writing this in such a way that it makes sense. So I got a little squished here. The moral of the story is try to use the full page to get your calculations done and don't squeeze yourself up against. There will be times when it's a mess, but learn from those times and practice doing this neatly and orderly, because you know what? When your mind is organized, your paper will be organized. And when your paper is organized, it helps make your mind more organized. I wish you could see my hand gestures. They're so spot on, but you really can't. But I'm telling you, it makes a difference. I'm not one of those people who thinks you can just chicken scratch all over the page and it'll be fine. Organizing your work makes a difference, and I want you to practice it now. Okay, There's my tough talk for the day, tough love for the math students. That is lesson 15. We survived surface area. I'm glad it's over with. Thank you, goodbye.